Hi, welcome to Essential IT and Security Skills. I'm Charles Redmond, Master Trainer, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series to some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. In this chapter, you'll learn how to identify the core components of the CPU, describe the relationships of CPUs and memory, explain the varieties of modern CPUs, select and install the proper CPU for your device, and troubleshoot. First, let's talk about the CPU itself, or the Central Processing Unit core components. The Central Processing Unit works as a very powerful calculator. CPUs really, in and of themselves, aren't very smart. They're just really fast at manipulating zeros and ones. To understand how a CPU works, let's try by illustrating an example for you. Picture a man in a box. Our first challenge is figuring out how to communicate with that man in the box. To do this, imagine 16 lights, 8 on the inside and 8 on the outside. When an inside light is on, the corresponding outside light is on. You can switch these lights on and off. This is what we call the communication system, or the external bus. The man in the box, or the CPU, he communicates with the outside world by using the external bus. It's a basic world of ones and zeros. The only problem is, the man in the box has no memory. So you're with me so far. Remember, it's a world of ones and zeros. 1 is on, 0 is off. Inside the box are work tables for the little man. We call those the registers. The 4 general purpose registers found in all CPUs are AX, BX, CX, and DX. So for the man in the box to understand the world of ones and zeros, we need to give him a cookbook or an instruction set. We call that the Codebook. The Codebook is machine language. It's what the CPU understands. One command line is a line of code. The complete set of commands is the instruction set. So now we have our man in the box, his work table, little flashy lights, and a code book for him to understand. So it's important to remember that the CPU does no work until it's told, even though data may be present. You need a buzzer, if you will, to tell the man in the box to start. This is referred to as the clock. The clock speed is the CPU's maximum speed, not the speed at which the CPU must run. This is an important point. The clock speed is used to synchronize internal and external activity. 1 cycle per second equals 1 hertz. 1 million cycles per second equals 1 megahertz. Each command requires at least 2 clock cycles. The clock speed is essentially the maximum clock cycles per second. A clock cycle is the time taken by the special wire to charge. Remember, the CPU needs at least 2 clock cycles per act on each command. So what makes clock cycles work? Well, it's the system crystals, or crystal oscillators, that governs the CPU's running speed. Most modern motherboards use jumpers to select the crystal speed. Crystals can clock a CPU with the rated speed higher than the crystal, but the CPU will only operate at the slower speed of the crystal. So you've probably heard terms like underclocking and overclocking. Well, really, underclocking means running a CPU slower than its rated clock speed, or overclocking means to run a CPU faster than its maximum clock speed. Overclocking can be extremely dangerous to your PC. Now remember, the man in the box has no memory. Essentially, the memory is the computer's workspace. Programs and data are stored in storage media, either hard drives or flash drives, or we'll get to that later. But the media isn't fast enough to provide the data to the CPU. So it needs somewhere to store that data so that the CPU can access it much faster. This workspace is what we call RAM, or random access memory. It's organized kind of like a spreadsheet, each row holding 8 bits or 1 byte. It's important to remember that RAM is volatile. It means without power to the PC, everything stored in RAM disappears. Now, the number of bytes of RAM varies from PC to PC, with today's PCs holding billions of bytes in RAM. Computers also use DRAM, or dynamic random access memory. Dynamic rather than static, random rather than sequential, provides for a very efficient manner to provide the man in the box the information or data that he requires. So now our next problem. The man in the box, the CPU, doesn't know how to talk to memory, so it needs a little helper chip, if you will. Enter the MCC, or the memory controller chip. It's a device that facilitates the flow of data from RAM to CPU so that the man in the box understands the commands that you want him to perform. So how does the MCC, or the memory controller chip, talk to the man in the box? Well, it needs its own special communication channel. That's called the address bus. The address bus enables the CPU to control the MMC so that it can get the data that it needs to execute your instructions. There's no set number of wires for the address bus. However, the number of wires for the address bus determines the maximum amount of RAM the CPU can handle. For instance, an old 8088 computer had 20 wires, which, if you do the math, provided 2 to the 20th combinations, or 1 megabyte. Today's PCs, however, use 36 wires. That's 64 gigabytes of possible RAM. Now, I know I'm throwing a lot of strange words at you, like bits and bytes, and all you have to do is understand a bit is a simple 1 or 0. It's the light in the box. 4 bits, we call that a nibble. 8 bits is a byte. 16 bits, a word. 32 bits, a double word. And 64 bits is a paragraph or a quad word. Most commonly you'll hear it used as a paragraph. So which bit or byte are we talking about? Well, just simply look for the capital letters. A lowercase letter b, we're talking about bits. An uppercase letter B, or a big B, we're talking about bytes. Now that you understand the basics, let's take a look at the modern aspects of today's CPUs. Essentially, there are 2 main CPU makers, Intel and AMD. Understand, on the outside, the CPUs may look extremely similar, but they're not interchangeable with each other. That is an important point to remember. Intel has basically dominated the world with its CPU and motherboards. However, AMD, or Advanced Micro Devices, has kept up with the competition in today's computer market. So which CPU is right for you? Basically, you can tell by the name. Most mainstream or computer enthusiasts, they'll stick within the Core for Intel or the Phenom series with AMD. Most of the lower-end desktop PCs, you're going to deal with Pentium or Celeron for Intel, or Sempron with AMD. Here's a simple chart to keep it all straight for you. Now understand, both of these companies use code names to keep track of the different variations within the models. So it's important to understand that CPUs labeled as the same model may have CPUs inside that are very different from the earlier versions. For instance, CPUs made for the desktop versus mobile devices. Mobile devices have needs that differ greatly from those of desktop computers. So both manufacturers have created both mobile and desktop versions of their CPU.
There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.